like to welcome my next speaker, Akansha Yakwani from Sixsense, who came all the way from Singapore. So welcome.
Ich wusste nicht, dass...
Hello. Please.
I'm Akanksha, co-founder and CEO at Sixsense. At Sixsense, we are reimagining the world of visual inspection using AI. This is a chip. It begins its life in a factory, grows there for 3 months, and then it dies. Problem is, factories don't even know when it died, which means they spend manpower and resources for 3 months for no reason. And this costs them billions. To make matters worse, we're in the middle of a global chip shortage crisis that has been trickling down its impact on multi-trillion-dollar industries. Such dire circumstances demand all the more attention to unchoking supply issues and improving the manufacturing processes' yield. But why should you care? Isn't it frustrating to have to live up with phones that can give up on you anytime, or cars that could blast anytime? Because a faulty chip made its way to your phones. We are living in a life where chips are of utmost importance to us. So the reliability can be a matter of life and death. To prevent such problems, manufacturers are collecting millions of images every year to spot one tiny defect. To do this, today, they're using traditional image processing algorithms. However, these algorithms give up when the defect catalog is very broad, which means if they have to identify and classify different types of defects, which are 100 and 500 in nature, the algorithms start making mistakes. They either miss defects or they annoy manufacturers with a lot of false alarms. To overcome this problem, manufacturers are using a second check where manufacturing operators are used in the line to analyze the problem. This adds to the delay in the production systems, processes, and efficiencies, and still does not solve the problem. Manufacturing operators have the problem of bias subjectivity that leads to errors still happening in the line. Very often than not, the lines are halted for few days to few months sometimes, just to be able to locate what is the real root cause of the problem is why the defect happened at first place today. With AI, we need not rely on decade-old ways anymore. Introducing Classif.AI, an end-to-end software platform designed by manufacturing experts and is powered by deep learning and computer vision. Classif.AI reviews images 24/7. It remains alert always and identifies defects even the slightest sign. Some of the world's largest manufacturers are using our technology today. They're looking at 40 million images every year that were earlier reviewed by 40 operators. Our installations have proven significant ROI in terms of yield gain, worth tens of millions of dollars for these manufacturing companies, have shortened the life cycle of the process, and has also shown them inspection efficiency by 90%. 12 more manufacturers have lined up and have signed automation initiatives projects with us. And we don't stop here. We think it's a global problem where the technology that we have built is also benefiting the machine makers. They can integrate our technology in their equipments, can make real-life decisions on the go. And we're also looking to explore use cases with other high-tech manufacturing verticals very soon. While there are a lot of AI products today, our team of manufacturing experts and AI have figured out by closely working with manufacturers of what is stopping them today to adopt technology. And we identified key 3 areas where Sixsense has developed unique offerings. Number 1 is explainability. While building a model is hard, debugging is even harder. This is where we have baked in explainability into our solution. If AI detects a chip as faulty, it shows similar looking images that has been in the train set to tell them why AI calls this chip of class A. This helps them debug the models faster and locate data quality issues in being able to deploy the best quality models in time. Also imagine when these manufacturers have to report to their end customers, auditing and reporting, these systems become very helpful and handy in being able to trust an AI system, which is neither a black box currently. Second, Classif AI is intelligent and domain specific. Evaluating the quality of a chip means looking at it from many different magnifications. And it is much more difficult than classifying cats and dogs. Classif AI has been painstakingly tailored to manufacturers. It provides the right training parameters for different scenarios. And this has proven 50% improvement in accuracies for certain use cases in semiconductor manufacturing, where one doesn't have to be an AI expert to launch AI models within hours for any kind of image data and defect types. Lastly, adaptability. While the rest of the industry, we have also learned the hard way that the machine learning journey does not stop at model deployment. Classif AI learns the variations of defects and helps manufacturers proactively understand when a machine learning model needs retraining. This has helped them save 30x time that they have been currently spending in manually operating and maintaining the models today. From labeling data to training images, to being able to launch and deploy models at speed, Classif AI has it all. If you're a manufacturer looking to smoothen your journey and fasten the speed, please visit us at our booth. Thank you very much, and to the Vision Conference for hosting this event. We're looking forward to be collaborating with many of you.
Anja from Sixsense. Any questions? Mark, please.
Hi. So before I ask the second question, the first one is to my understanding is this isn't being applied on the AOI machines. It's on the manual inspection afterwards, and from what you're saying here, you have how many have you got deployed now? How many customers and sites have you got deployed?
So there are 4 factories which are currently using our technology, and there are 12 more which are in pilot stage with us right now.
Okay.
Yeah.
Okay, brilliant.
And the second application is on AOI, which is where we'll be partnering with equipment makers because it has been proven outside the systems currently.
And your customers have installed your system, and they have brought in their own data, and they have tuned the system with their data, and you haven't seen these data.
So we did see the inspiration of data because that helped us tailor our algorithms to a specific data set. But imagine the scale in a semiconductor manufacturing where they have 150 different inspections in the life of 3 months. So what we have seen is samples all across the inspections, but the real model has been prepared by the users of the factories for 150 different inspection layers. We teach them in 1 or 2 layers, and then they scale it to 150 inspections from there on.
So is there any generalization inbuilt, like there's some knowledge gain at one customer, and you get perfectly retrained, adopted models, which you can then use at another customer?
That's perfectly right. The transfer learning, just the domain understanding of how typically defects are looked at by humans. So there are certain complex processes. For example, image, along with the location of it in the unit, defines the type of defect. All of that has been learned over months of talking to users which are using the product currently.
Okay, thank you.
Thank you. Last question. Donato, please.
Very quick one. Do you focus on the front end of the process, or the wafer level, or the package chip?
At this today, both.
Both?
Yeah.
But the defects are very, very different.
Exactly. But the training pipelines that we have developed have been able to fine-tune the data sets both from the Fabs and from the back-end assembly and packaging sites currently.
Thank you.
Perfect. Thank you, Akanja.
Thank you so
from
much.
Sixsense.